Hello guys, my name is Craig and welcome to Payment Solutions. So if you're new to my channel, please subscribe and hit the notification bell so that you don't miss out on any new videos. Today we are looking at how to differentiate exponential functions and logarithmic functions. But before we start, there are two very important general derivatives that we have to know. So the first one is that d by dx of e to the power of x, which is the derivative of e to the power of x, is equal to e to the power of x. Then the second derivative that we have to know is that d by dx of ln x is equal to 1 over x. Okay, so now we can start. So for a function, we're going to start off by looking at differentiating exponential functions. So now for a function, say y is equal to e to the power of u, whereby u is equal to f of x. Right, here we know we can use the chain rule to find dy by dx. So we know if we find dy by du, for which we said the derivative of e to the power of u would just be e to the power of u. Then we find du by dx. Du by dx will give us f prime x. Right. Such that dy by dx, dy by dx would be equal to dy by du times du by dx. So dy by du we say it is e to the power of u times du by dx, which is f prime x. F prime x simply being the first derivative of the function of f of x. So now this is what we get, and you can rewrite this result as dy by dx is equal to f prime x times e to the power of u being f of x. So this is the result that we get when we differentiate e to the power of u, whereby u is a function of x. F prime x times e to the power of f of x. So now I would like to attempt these first four questions that require us to differentiate the following exponential functions. So as well, allow me to write this general result. Let me put it in green. Okay, so we are saying d by dx of e to the power of u, or let me say e to the power of f of x. Yeah, that would make much more sense. E to the power of f of x is equal to, we put square brackets here, is equal to f prime x times e to the power of f of x. So this is the general quotable result. So now allow me to erase this. Right. So for the first one, we've got d by dx of e to the power of, removing the square root sign, we know that's to the power of half. So that's e to the power of x plus 1 times half, which is to the power of half times x plus 1, such that this is our f of x. And then we say f prime x, so differentiating this power, right? Differentiate what's inside the brackets, we get a 1. Multiply by half, we get a half. So that's half e to the power of f of x. So this is for the first one. Then for the second one, right, we've got e to the power of minus 2x. So minus 2x is our f of x. So we say f prime x, differentiating minus 2x, we get minus 2. Then we multiply by e to the power of f of x. So this would be the answer that we get. Then for part C, right, d by dx of e to the power of x squared plus 1. So now f of x is this quadratic power, which is x squared plus 1, which when we differentiate to get f prime x, we get 2x. Then multiply by then multiply by e to the power of f of x, x squared plus 1. So that's what we get. And then now for the last part, d, we are saying that now our f of x is this quadratic power, which is 3x squared minus 2x. So f prime x would be what? Would be 6x minus 2, because we're saying 3 times 2, when we drop the power, multiply by x, then subtract 1 from the power to get 6x, then minus 2, because we're saying x to the power of 1, dropping the power 1, multiplying by 2, then multiplying by x and subtracting 1 from the power of 1. We simply get this. So this is our f prime x, and then times e to the power of f of x, x squared plus 2x. Okay, so this is what we get for part D. And then these brackets like that. Okay, so now this was differentiating exponential functions. Now I would like to move on to differentiating logarithmic functions. So allow me to quickly erase this. Okay, so now for differentiating logarithmic functions, we are saying that for a function y is equal to ln u, whereby u is a function of f of x. Right, we know that we can find dy by dx using the chain rule. First we find dy by du, but we said d by dx of ln x will simply give us 1 over x, so dy by du will be 1 over u. Then we find du by dx, which would be f prime x. So now our dy by dx would be equal to dy by du times du by dx, which is 1 over u times f prime x. But we know that it's f prime x over u being f of x. So this is also a quotable result, which we are saying that d by dx of ln f of x, ln f of x is equal to f prime x over f of x. So in other words, we are saying the derivative of f of x over the f of x. So now let's attempt those 4 questions real quick. Okay, so now for the first one, part E, we see that this is our f of x. So we're simply saying dy by dx, this is for E, is going to be differentiating this f of x, we get 1 plus 2x, so 1 plus 2x, because we know when you differentiate 1 you get a 0, when you differentiate x we get a 1. Then when you differentiate x squared, we're dropping the power 2 multiplying by x to get a 2x. So we're saying this over f of x, 1 plus x squared. So this is what we get. And then for part F, dy by dx is equal to, our f of x is 2x squared minus 3. So differentiating that, we're saying 2 times, dropping the power 2 multiplying by x, then subtracting 1 from the power of 2, we get that. Over f of x, and then when you differentiate a constant, we say we get a 0. So that's just 2x times 2 over 2x squared minus 3, which you can further on simplify to 4x over 2x squared minus 3. So that's what we get. And then now for part G, dy by dx is equal to f of x being 5x plus 2. We're saying the derivative of that will give us a 5 over the linear function 5x plus 2. So that's simply the derivative. And then for part h, dy by dx is equal to 3 minus 2x squared. So we're differentiating that quadratic function, and we get minus 2x, because differentiating 3 we get a 0, then minus differentiating x squared, dropping the power 2 multiplied by x, then subtracting 1 from the power, over 3 minus x squared. So that's the result that we get. Okay, so this was looking at differentiating exponential functions and logarithmic functions. Please feel free to leave a comment, drop a like, and don't forget to share. Thank you.